Once again, I would like to thank the Dean of the art classes, Violeta Dinescu, and the Dean, of course, of the medicine class, Dušan Šuput, and the Dean of the class of natural sciences, Johannes Leritzis, who initiated with Violeta together this nice series of events. Tonight program is about music, painting, and quantum mechanics. How can they be connected? Because that's what this event is all about. The interdisciplinary connections between art and science. Quantum mechanics is the basis of the physical worldview today. In Munich, my home university, we have a priority program of quantumness, which is not only about applications in quantum computing, but also applications in the social sciences, humanities, and arts. And some members of our academy are involved in this program. Now, therefore, at first, I would like to briefly remind you of a few, actually two principles of quantum mechanics. In classical physics, we assume that, for example, the position and the momentum of a body can be measured simultaneously with arbitrary accuracy. According to Heisenberg's uncertainty principle, and that is my first principle, which I want to highlight this evening, the more precisely we try to measure the position of an elementary particle, the more the measured value of the momentum scatters, and vice versa. Location and momentum are examples of so-called conjugate quantities. Our speaker this evening will discuss these quantities in the context of musical theory. In the 20th century music, that is my interpretation and impression, for example, in jazz or blues, blurriness is immediately apparent. Modes are not clearly, for example, either happy or sad, but perhaps something between intermediate these two states of emotions. Obviously, the mathematical formalism of quantum mechanics is by no means limited to elementary particles and physics. Another central principle of quantum mechanics, which differs from the classical world, is the superposition of states. Erwin Schrödinger, the Austrian Nobel Prize winner, explains this in a famous thought experiment of a cat that can be dead and alive at the same time. And I underline for all our friends of animals, this is only a thought experiment. Imagine a cat enclosed in a box together with a radium preparation. If the radium preparation decays by random, that means with a 50-50 probability, a poison is released that kills the cat. As long as the box remains closed, the cat is equally likely to be dead and alive. If the box is opened, the cat is either dead or alive for our observation. In Schrödinger's interpretation, opening the box corresponds to a measurement of a quantum state. The superimposed state of dead and alive, mathematically a probability wave, collapses into one of the two possible classical states which can be observed. Now, why do I mention this second principle? Because I think it has some relations to our other coming up lecture or talk, because superposition of states can also be expressed in painting. In this next lecture this evening, the speaker will explain how in a painting by a Slovenian painter, the Virgin Mary merges with the angel Gabriel in the act of the biblical Annunciation. A kind of superposition, if you see the picture later on, a kind of superposition that gives rise to many theological interpretations. Modern painting had more different ways of expressing states than in classical traditional painting, in which persons and states were clearly separated and distinguished. By the way, that was also used by Paul Klee. He was a musician, but also a painter. He used this technique. It is remarkable that this painting of this Slovenian painter was created in 1922, at the time when the foundations of modern quantum mechanics were being laid. The painter was perhaps not aware of that. But anyway, for me, this shows that subliminal currents are developing between art and science in the history. In the end, art and science are just different means of expressing a common reality. So it's going to be exciting and thought-provoking again tonight. I wish you a good discussion. Thank you.
Thank you very much. I'm now presenting Thomas Noll, the first speaker tonight. Thomas Noll is a German-born music theorist renowned for his pioneering work in mathematical musical theory. He holds a diploma in mathematics from Jena and earned his PhD in semiotics from the Technische Universität Berlin. He led an interdisciplinary research group focused on mathematical and computational music theory at the TU Berlin. Since 2005, Noll has been a lecturer in music theory at the Escola Superior de Música de Catalunya, Hochschule für Musik in Catalunya in Barcelona. His research integrates mathematical concepts such as group theory, monoid actions, and algebraic combinatorics to explore musical structures, including harmony, voice leading, counterpoint. He had published over 50 journal articles and book chapters, and he also served as a co-editor of the Journal of Mathematics and Music and received 2013 a Society for Music Theory Outstanding Publication Award. I'm very happy to say hello to Thomas Noll, and thank you very much for coming to us. Please.
Thank you very much for the invitation. And I'm very glad also, I'm very thank you for the introduction by Klaus Mainzer, which I think very nicely fits to the intention which I have to explain you. So let's go to the moment when quantum theory was started to be developed. By that time, it was actually the vibrating string which served as a model for de Broglie and also Schrödinger to explain why the electron orbits would have to have an integer number of, so to say, states, possible states. And therefore, there's a quotation from Schrödinger's article where he actually mentions the vibrating string. So to say, the violin was an inspiration for quantum theory. So after 100 years, it might be a good time to get some inspirations back. to music. And there are a couple of articles already published. Also, there's an incidence at that time, also in the 20s. On the one hand, we have the wave equation, Schrödinger equation, where actually Schrödinger says it doesn't matter whether all these concepts, energy, power, a force, impulse, whether they really exist or not. What matters is that they serve us to explain how things work in physics. While at the same time, there was a music theorist, musicologist very close to Zurich, in Bern, Ernst Kurt, who was a phenomenologist and who claimed that when we hear music, then the acoustical signal is just a stimulus for our mind to experience motion, experience power, force, impulse, and all these things. So it's an interesting incident that at that time two such contrasting views have been articulated. And I'm not aware of a personal contact between Schrödinger and Kurt. So in my abstract, I told that I will give first 3 motivations from inside music theory why it could be interesting to work on quantum ideas in music. And then at the end, I will explain, actually give a report on some work in process. So the first motivation has to do with the musical scale, let's say the major scale and the notation system. What you see is a note carpet. It is a didactical tool which I developed for a video series, also in the pandemic context, so present music theory online. You can search this under the title Musiktheorie auf dem Notenteppich. So there is the vertical dimension, which is simply the staff lines of music notation. But there is a second dimension, which is the chroma dimension. It goes sharpward, so the sharps go to the right side and the flats to the left side. And they are ordered in the same way as the scale degrees vertically. This carpet is like a chessboard, you can see. And actually, any note can take any position on that carpet, which means that in music, and tonal music, and also modal music, the notes change their meaning according to the context. And I like to make a metaphor with vision. Like in our eye, we have the Netzhaut, I don't know the English word for that, so where we project the external images. But at the same time, we move our eyes, so we have the capacity to integrate the motion of our sensory organs with the external motion, and our mind is capable of understanding both things together. And I think the same capacity takes place when we hear tonal music, and where we hear changing pitches on the one hand, so the notes change, but also our position in relation to the notes are changed. So, and I go quickly through some slides which show this in a more music theoretical way. So we have the octave divided into 7 scale steps, but at the other hand, we have these this is the more abstract thing which has not a spatial representation in the musical notation, the sharps and the clefs, but they create a second dimension. And so actually you can represent all these musical intervals I hope you see my mouse. If I show things, here's the minor second and the major second, the minor third, the major third, the perfect fourth. So all these intervals have their place in this two-dimensional grid. And you can either access them all in terms of major and minor steps. So you can represent all other intervals as superpositions of minor and major steps. Or you can take the perfect fourth and the perfect fifth as a way of accessing them all. And both ways are important for our musical understanding. So there's actually a transformation which translates these two ways of accessing musical intervals to each other. This is a more geometric representation. So here we represent all the intervals in terms of fifth and fourth, and here in terms of steps. And this is a 2 times 2 matrix, is a transformation which translates this into each other. And actually the same kind of matrices occur in mechanics, in geometric optics. They are known as canonic transformations. And one of my speculations is that maybe our capacity to translate these two ways of accessing musical intervals is based on the same capacity of our mind to understand, for example, optics, so the vision, or any kind of dynamics, Hamiltonian dynamics. Just to give you one musical idea of what happens here. So this is this transformation. Yeah, we have all the musical intervals in terms of perfect fifth and fourth, or major and minor steps, and we have this transformation. As a subspace, we have octave and the sharp and the flat sign. So if we ignore them, that means all the C's are the same, and if we identify F with F sharp and B with B flat, we get just 7 scale degrees. And then this transformation is nothing more than just multiplying by 4. And actually, this is something which happens all the time when we hear sequences. I have here a tune. This is da da ba da da. This is "Fly Me to the Moon." Yeah, and in this tune, you see that the harmony goes in fifths, no? From A to D to G to C to F and so forth. But every second bar, you go a note lower. So you see these 2 bars is just a copy and paste of the next 2 bars and so on. So that means if you go 2/5, this is the same as if you go 1 step. And if you go 4 steps, this is the same as if you go 1/5. So this, you can view this as a circular definition of the scale. Here, this formula. 2 times 4 is 1 modulo 7. And it explains a lot of musical sequences in all the repertoire from Baroque till tango and jazz. One more comment on I have to, there is 2 ways of folding, for example, the C major scale. No, we can start from B natural and go fifthwise, or we can go the other way. And if you count, we need, for example, 5 major steps and 2 minor steps to fill the octave. And you can view them like, as kind of frequencies, 5 and 2, and octave and fourth and fifths are like periods. So there is a kind of like in Fourier theory, conjugated variables, frequency and a period, and there might be an analogy behind this. There is also a remarkable property which was already discovered by Guido of Arezzo, that we have 2 copies of the first 6 notes of the scale in the 7 notes. This is, and he was quite excited about it, and it explains why we could have the organum, so the medieval way of repeating a chant at the parallel fifths without leaving the tonality and without having 2 different melodies. And the same property is responsible for all these imitations in the Renaissance music when we have one voice imitating the other at the 5th or the 4th. So there are quite remarkable properties which are a consequence of this 2-dimensional constitution of the tone system. The second motivation has to do with 20th century music theory. There the music theorists were motivated to classify all the chords. So there is a theory in American, especially American music theory of the 70s called pitch class set theory, where one views chords as being made of notes, of single pitch classes. But there was a different approach which became quite successful in the last years, namely to view chords as superpositions of, let's say, of sinus functions. Not in an acoustical sense. Let me show you. There are nice articles by Jason Just, and there is this book by Emmanuel Amiot. Let me just show you these videos. So what you see here is like sine waves at different frequencies, but the space underneath is the 12 notes. So it's not time, no, it's not something acoustical, but it's just, there's one more. Actually, there are 12 of them, but it's enough to see these 6. So, and you can view a chord as saying either C is a member of the chord C sharp not, and so you can describe a chord as a series of zeros and ones, and this can be analyzed as a superposition of sine waves. And it is very insightful to do that. I show you. So you see that. I better skip the details. Just to show you how this works. If you take a musical piece like Bach's first prelude, you can view, you can kind of take a window, a sliding window through the piece at different sizes, and you get a lot of notes there. And you can analyze these notes with this method. And the analysis looks like this, what you see here. For each of these partials, the Fourier partials, you get a triangle where the brightness of a certain point, of any of these points, represents the energy or the magnitude of a Fourier partial in this segment. And the color shows the phase. So you have magnitude and phase, and for every segment of the piece, you get a brightness value and a phase. And it is quite interesting to see that this 5th partial has a lot of energy, and it is just mostly one color. And if you translate this to music, it means that this piece is in C major, and that it deviates a little bit to the dominant and back. While the 4th and the 3rd partial, they have all these changing phases, colors, which are the chords. So you can really make a one-to-one translation between a Roman numeral analysis of the piece with these colors. And an opposite example would be a piece by Scriabin, Prelude, the 2nd prelude of his last collection of preludes. And there you get a similar result with respect to the 4th component, which is, so to say, stable, while the 5th and the 3rd are more variable. And this represents the fact that this is a more octatonic piece, that these pieces are governed by an octatonic scale. So the message is that these Fourier qualities, as they are called, so that it makes sense to say chords are not just made out of single notes, but they can be seen as superpositions of these Fourier properties, of these Fourier partials, and one can really use this for analysis. So what has this to do with quantum theory? Actually, before I explain this, I actually jump into how we get into quantum theory from looking at tonality. So there is a third way of looking at tonality, which is more for the empirical one. So there are experiments where people have to rate the importance of the different notes with respect to a key. Now you get histograms like you see here. So D flat and E flat and F sharp, and so they are not so prominent in C major, while E and F and G, they are. No? So, and these histograms have been used a lot in empirical music theory. So there was an idea by Reinhard Blutner. He is on the right side. What happens if we reorder this histogram along the circle of fifths rather than chromatic? And it looks much more much more easy to grasp. And in the present work with Peter beim Graben, we used fitting of this with a Gaussian mixture. So you use 3 Gauss curves to fit this this data. So, and this is the entrance to quantum to a quantum approach. Namely, I have some formulas here, but don't be afraid. So there is I have to put it to the other side. So there is a famous model of the one-dimensional quantum model, which is called the quantum harmonic oscillator. And there, this is a Gauss curve. So the Gaussian is known to be the fundamental solution of this situation. The point is, in physics, these probability functions, as I showed you, this histogram can be seen as a probability function. It's just a method to access a deeper level of wave functions. While in many empirical sciences, one is just fine to look at the statistics as a dead set of data. So what we are intending here is to take this data from empirical research and look for a wave function which has this as a probability density function. So so in the normal quantum harmonic oscillator has a very quasi-classical solution, which is a Gaussian, which is moving back and forth. So this is called a coherent state. What we are trying is to do the same thing, namely taking the square root of this Gaussian mixture. And my colleague, Peter beim Graben, was actually able to find a Schrödinger equation and to solve it for this situation. So I skip all these technical details. This is anyway being published. But you can, let me go to this picture. So instead, so for the classical harmonic oscillator, you have this kind of quadratic potential, which explains the potential energy of this. And in our case, we have this little bump here, and which gives a perturbation to this oscillator model. So let me just show you a little movie. I skip this here. So what is the essence, what we get in this quantum model, which we don't have in this that statistical level? This is again our curve. You see this like in the Little Prince, the elephant or the head. This is this curve. It is the ground solution of a Schrödinger equation, which remains stationary. So it means it actually, when we look at the dynamics, it does not move. But if you use it like a pendulum and move it, one can take any wave function as an initial state and see what happens to it if I use this Schrödinger equation, the Hamilton operator. And what I show you here in this movie is a fifth. So it is the same tonality like C major, but moved by a fifth, so to say, as if we go to G major, but we don't. It's just an deflected version of C major. And here on the other side, so the connection to Fourier is we have these conjugated variables, position and impulse. So the Fourier transformation actually is the mediator between the position representation of the wave function and its impulse representation. So you have here you see both at the same time. So let me play this movie. So it's just it goes from infinity to infinity of the time. So this is what physicists cannot observe. It is the theoretical model of how this wave would propagate in time. Actually, to measure it, one needs this statistics. One needs the probability density function to make predictions and then to locate the particle. But this is actually the hidden dynamical behavior of this wave function. So so this is, so to say, what we get if we say, oh, let's take the empirical data and let's view it as if it is the probability density function of an underlying Schrödinger equation. So what to do with this? The one idea I'm following with Peter Baumgraven is to interpret these dynamics in terms of tone transitions and other things. Together with my colleagues in Barcelona, we follow an idea to apply this to actually create musical processes. And so, Violeta, how much? Now I'm already 5 minutes over.
Maybe shorter now.
Yeah. Just so.
Thank you.
We call this is a paper it is accepted at the ICMC in Boston in June. If you have this wave function moving, maybe I go back for a moment and I play it while explaining. So here I actually have this line of fifths again. So that means at each point you get at each time a specific magnitude, which is the height, and a color, a phase. So that means, and what I want to, so to say, motivate with this graphic, this is the same data, but just given as a landscape. So you have time going from front to back, and these are here the positions. So the Hamiltonian, which is the energy operator, now gives us a kind of unity to this process. So it's all this is one dynamics. And the idea here is that if we have many voices, we can use this data to make a kind of heterophony. And each voice can get its own process, but nevertheless, the dynamics guarantees that this is actually a unity which is provided by the Hamiltonian. So that means we have these different observation points, which can be different tracks of a score, different instruments, and each of them one can control a certain parameter with this. And as an example for today, I did actually an experiment with like 15 voices, and I used the data from this video, and I can provide this later in the chat. So I uploaded an audio, but it takes 10 minutes where I tried to sonify this process, which we see here. So it's a kind of combination of both ideas. So this is a very idiosyncratic, let's say, approach to quantum theory. There are many others at the same time, coming from quantum computation and also from the analogy between sound and quantum theory. But
thank you so much.
but this one, yeah. So that's the last slide.
Yeah. Wonderful.
Yeah.
Thank you so much, Thomas. We shall speak about after the second
Yeah.
lecture.
Yes.
Thank you very much. It's really fascinating. Now we have Dušan here. Hello.
Yes.
Dušan.
I stop my sharing moment.
But I shall present now Boštjan because so I prepared to present Boštjan. So Boštjan Marko Turk is a Slovenian scholar specializing in.
Well, maybe, yeah, okay. We present him. You can present him too. Okay.
Oh, okay. No.
No problem.
Dušan, if you already are, because if you would like to present, I would be very happy. Please do it.
Well, he's my countryman, so maybe it's
Yeah,
good that I do it. I just landed
I didn't know you come. Okay.
at the airport, and I stopped for this moment. I enjoyed the previous lecture that showed again and again that mathematics is not only the language of art, of science, but also language of art. And Professor Boštjan Turk, he comes from the same university as I do in Ljubljana. He's been first vice dean and then dean of class 1. And I'm kindly asking you, Professor Turk, to start your lecture. Thank you.
I'm mute.
Boštjan?
Boštjan, I'm mute.
Unmute yourself.
I unmute, yes. Do you see my screen sharing? Everything is okay?
Yeah, it's okay.
Yeah, nice. So
yeah, just in case if I lose connection, please excuse me. I'm really on my way, and I hope I will be able to stay till the end. Okay.
It's a sort of miracle you are with us.
Don't worry.
So I would like first express my gratitude to Professor Mainzer to make a parallel that was very intriguing for me, and to present in a way my subject of my communication. And then I would like to thanks also Violeta and Ioannis, my friends, to accept, and Professor Šuput to accept my presentation. And I'll try to do my best. So First, let me explain how I get in contact with this canvas, which I found just adorable. I was looking for a cover for my book, which is here, for my recent book, The Prisoners of Liberty. And the book is about, I would make a short introduction. The book is about the Slovenian history. I took the image of the Annunciation. So what I'm talking, I took the image of the Annunciation, because the Annunciation, as we see, is the word that has been made flesh. Verbum caro factum est. And to illustrate the how to say, in a way, tragical part of the Slovenian nation through the history. The Slovenian nation started in 8th century with the settlement of our ancestors. They came from the west, and the first monument we had was the monument of Brixen, Monumenta Freisinghesia. It's also the first text in Latin alphabet of one Slavic languages. It is in Slovenian. But from the 8th century to the 1991, the Slovenians could organize itself in writings and so on, in culture, and we become a nation. But there was no state. We could not form a state. And with the collapse of the Soviet Union, with the collapse of Yugoslavia, the flesh, so the word became the flesh, and the Logos, I would say, engendered the Republic. And in June 1991, the Slovenians got their state. So that was the initial idea, the Annunciation, verbum caro factum est. And secondly, then the canvas started to engage me, and the image increasingly captivated me, for the reason, perhaps, from the point of view of the church, it could be, and it is perhaps, a heresy, because it's not something that comes with direct teaching. But I started to ask myself why as you see, those both figures of Virgin Mary and Angel Gabriel are presented merged together. There's no distance between the Angel Gabriel and the Virgin Mary. Plus, there's if you see the face of Virgin Mary, so the angel is without a face because he is merging in a way. But if you see the face of Virgin Mary, and if you see the serpentine figure of the Virgin, and the serpentine figure of the angel, and the serpentine lines back in the background, you can admire a sort of profound, subtle eroticism that's painted here. And so I was wondering what's behind, and what I have discovered I'm sharing now with you. But first I have to make a short presentation. Who was this genius painter, who is Slovenian? It's Francesc Krah, who was born in 18. So I pass to the second slide. In 1895, and he died of a cardiac arrest in 1960. And he was not, what's very important, he was not only an artist, but he was a witness to some of the most violent changes in European history, by which Slovenians were particularly concerned. So he faced, at the age of 18, he started to studying sculpture at the Vienna Academy of Fine Arts, but there was the outbreak of the First World War, and he was engaged in the trench combats, and he was wounded seriously. He survived, but bears the scars of physically, mentally, and so on. He continued to bear the scars of this conflict. And the experience after the First World War pushed Krah towards expressionism, is a style that was born out of chaos and suffering of that time. But expressionism, and there we are touching the essence of the Kral's work, it's not just how the world looks, it's how it feels. And Kral worked independently, and he promoted himself he made expositions, and he got for two of his figures, he was awarded the silver medal at the Paris exposition in 1937, which is an outstanding achievement. And his style evolved during the time, and the spiritual dimension became stronger as Kral matured. He turned increasingly to sacred themes, not just of faith, but in a way to resist the totalitarian regimes. That was the first he experienced the Italian fascism. And as we know, the Italian fascism was in a way linked to the Italian church, and the Slovenians were a sort of a victim of both. But we're also big victim, and Kral particularly, of the third regime. So I'm not talking about church as a totalitarian regime, but I'm talking about the circumstances, the concrete circumstances in 1920 in Italy. But in 1953 in Yugoslavia and in the former Socialist Republic of Slovenia, the Kral, the communist regime, took his pension away, and it was a very, very critical situation for him. And as a sign of protest, he went to the National Gallery in Ljubljana, and there he covered his paintings who were exposed there with labels in the sign of protest. He never bent, so that's how to say, he's a key figure, and not just an artist. And as an artist, he's exquisite and something really outstanding. But as an inner figure, as an inner character, he never bent. He never bent a knee in face of any regime, fascist or communist. So first, Francesc Kral was passing to the third slide. So the third slide, expressionism and personal revelation. For Kral, expressionism.
The slides are not. Oh no, you have it. Okay.
Yes, I think.
Another one.
Do you see? Do you see? Everything okay, Violeta? Okay, nice.
Yeah.
So for Francesc Kral, expressionism was more than just an artistic style. It was a way of life. After the trauma of the World War I, he found that the traditional realistic way of painting could no longer express the chaos and the sorrow he carried inside. And the sorrow was common to the older generation of the artists that were working and promoting their works in the years 20 of the past century. Expressionism gave him, to Kral, and gave them a visual language to turn pain into form and to turn protest into a beauty. And Kral did not create in haste. Each of his work was carefully planned and deeply felt. He painted what he lived, the wounds of war, the fear of the dictatorship, the loss of home and faith. And in the relation to that, I have to underline and to highlight his brother, who was Tone Kral, and his brother was very courageous. He's a painter of also great gift, and his brother was very courageous because he painted the murals with sacred motifs. The murals in the churches, some of them can be seen already, can be seen also today, on the western frontier of the Slovenian ethnic space. You know, after the First World War, after the Treaty of Versailles, the third of Slovenian ethnical space belonged to Italy, was becoming fascist since the march on Rome in October 1922, and one-third of the Slovenians stayed in Austria and in Hungary. And so the brother of Franze Kralj, Tone Kralj, was in a sort marking the western frontier by the mural paintings, in which it's very interesting, and you can see on the in my article published in EASA. You can see he configured the faces of the evil spirit. He configured the faces of the evil spirit because there are many representations. He configured them in a form that they represented Hitler and Mussolini, and that's very, very intriguing and how to say a very ingenious invention he made. And so the expressionism was Kralj's way to both brothers to challenge the system around him and them. And what's the problem is that the fascism and the communism, these ideologies had no space for metaphysical thinking, and they both tried to control not just the state but the spirit. And when this was happening, Kralj returned again and again to sacred themes, not as a dogma, but as a mirror for human experience. So these stories, and also the Annunciation. What's the final message of the Annunciation? The final message is that God is becoming flesh, that God is coming to the human body. Not to the humans, or to the human body, that he's bearing a human body, and he's bearing the misery of the human body. And the years 20, 30, and the World War II was the year when the Europeans experienced the most of suffering and oppression, especially the Slovenian nation. So there's a sort of a comfort which is coming to the Europeans at the moment. And now we are passing more directly to the Annunciation. The Annunciation. So it's a unique interpretation, something that I could not find a pair that the angel and the Virgin Mary would merge. I'll explain later on why. So it's an extraordinary work from its substance, something it's very peculiar that does not have a pair. And it was painted in 1922. Like Professor Mainzer highlighted, that was the year of discovery of quantum theory, but it was also the year of coming to the power of Mussolini, which was a process that has been prepared a long time ago after the First World War and the defeat in it. So the original defeat, and then so, but there are particular circumstances I shall not enter in. So it was 1922. It was a dark year in the European history, and because Mussolini came to power, and that he marked the rise of fascism. And Kralj was particularly, you know, Slovenians on the western frontier were all particularly sensitive to the political circumstances in those years. And to that we can link to the canvas we are in face, because in this version, as I said, of the Annunciation, something astonishing happens. instead of showing the Archangel Gabriel and Mary as two separate figures, as every painter before him had done, what's undeniably, Kral merges them into one. Their bodies are fused into single form. You cannot distinguish them because the Virgin Mary is covering the angel Gabriel, and the angel Gabriel is covering the body of the background of Virgin Mary, and that's very interesting implication. Why it is and what does it mean? I shall highlight in the next slide. So it's I think it's the key feature of this painting is the relationship. There's no relationship. There's the coexistence of the so-called divine time. We can just guess what it could be about, because all the terms we are using approaching God are analogical. We cannot talk directly. So divine time versus human time, and that's essential for the comprehension. So what I propose as a comprehension, that's essential for this canvas. So what's the difference? Generally, in human time, we live from moment to moment. Professor NOLL so made his presentation. He started at the point A and going to the point B, finishing. So it's a linear time. Everything has an before and has an after. We understand our events, our relations, and so on as events in line. And then the classic, as you know, annunciations from Giotto, from pre-Renaissance paintings, from Renaissance paintings, from Byzantine icons, and so on. There's a distance. There's a fundamental distance. First, the angel appears. Angel is always separated from Virgin Mary. First, the angel appears, and then we have an empty space, because angel is coming from the other realm of reality, from the other domain of reality. He's a transcendental figure. For that reason, we have an empty space, and then we have a Virgin Mary who is submitting, who is very neutral concerning her feelings. Franz Kral makes a Virgin Mary very engaged, very responsive, very beautiful, and very subtle in the way in the way of eroticism. I cannot speak about sexuality, but you can see yourself. And this is the Annunciation in classic painting. But here we have, because it is taking account of the human time, of the linear time. So first we have the Annunciation, angel speaks, and then we have Mary hears, and then we have she conceives, and then she gives birth. So there's separate on the line, the events on the line. But what Kral would like to show is that in the God's time, and that's essential, in the God's time, there's no distinction in the tenses we use to orientate ourselves: past tense, present tense, and future tense. Nothing like that exists. In God, everything is simultaneous. Everything is a big synchrony. Everything happens at once. So analogically, we cannot guess what is happening in God, because he is a transcendental being, and he's not something that the human reason could comprehend and could evolve, could understand. And what Kral would like to say is that in the moment when the Virgin Mary gets the message. She is already conceiving, she's already the savior in her is already growing, and everything is happening at once here for us. That would be in parallel with the God conception of creation, because God's time, it's not that God has created universe once forever, not. St. Thomas Aquinas, St. Augustine, Gregorius, and so on, they thought that God is that the being of God is, how to say, anything with the being of creation. It is all the time actualizing the universe he maintains in being. Without the being of God, being intervening with the universe, with the being of universe, the universe would collapse, would not exist. And that's the global time of God. Everything was, is, and will be. And that's the global time of Annunciation of Francesc Kral. What's of particular importance, it is that, you know, for people of the beginning of the 20th century, for people that lived in the 1920, 1930, that was an essential message, an essential message. Human race went from one catastrophe to another, from the First World War to the Second World War, from one totalitarianism to another totalitarianism. Slovenians, we left Italian fascism in 1945, 1943, with the capitulation of Italy, but de facto in 1945, to get the new totalitarianism as a communist regime that was, as I explained, particularly severe and cruel towards Kral. But the message of the Annunciation is that God has not made his announcement once 2000 years ago. No, he's making all the time. He has not entered once in the flesh of human being. No, he's entering all the time. His synchronicity is all the time doing. His being is all the time intervening with the being of the universe and with the being of the people. That's the particular message of Kral's painting. And then we can, so then if we leave the realm of the question of philosophical or ontological question of time, and we go further to the slide number 6. So it would be concretely what we see in the as a technique of painting, what we see in the Annunciation. So we see the lesson of El Greco, Domenicos Theotokopoulos, and the serpentine figures. Everything here is serpentine. So the Virgin Mary is serpentine, their limbs are serpentine, and the background is also serpentine. What does it mean? It means that this canvas is in a way moving from terrestrial reality to the transcendence. It's moving upwards. It's moving from the bottom to the top, and everything is very dynamic. And that's the lesson he took at El Greco, I think. So I cannot prove, but it would be El Greco is the great master of serpentine figures. His painting would not exist without it. And another thing is cubism. That's because we see the space. It's not static, but the space seems to fold around the figures. So they are multi-dimensional approach Kral has. The space is not, how to say, passive. The space is active. The space is active in this because the space is receiving the message of the Annunciation, will receive the Savior. I would pass to another because the time is I'm running out of the time. I would pass to another slide. Sacred Protest, Art as Resistance. So I would like to skip the slide because I have explained enough, and I would not like to be impolite to abuse the time I have been given. So what's also very, very, very important to understand this canvas, and it would be my final message of the Annunciation. It is that we cannot understand fully, and that's how to say. What I shall say is not. It's sort of a heresy, but I think it's a heresy founded in church documents and church councils. What I mean with that. So to understand completely this canvas, we have to go forward. We have to go backwards. We have to go to the first centuries of the Christian era, and the predominant question in that time was the nature of Christ. What was the Christ? So we know the other heresies. The Christ just was apparently human, Docates, and then Arianism, and so on. And then it was the Council of Chalcedonian Council, very, very important, in 451. Very important because it has defined the nature of Christ, and therefore since then we are talking about the hypostatic union. Hypostatic union, it would mean that both the human and the divine nature coexists in Jesus. And so the direct consequence or a logical conclusion out of that would be that Christ as a human being was or is prone to everything what we as human beings conceive. Also the eroticism, also the sexuality, also the attraction from other sex, from other gender, and so on. Denying that would be denying, logically, formally, would be denying the human nature of Jesus Christ. And for that reason, I see that subtle eroticism on the face of Virgin Mary and the very, very, how to say, sexualized figure of her body, because she is, in a way, if you see, she is in a way, her hands and her body, her hands are in a way of surrender, of accepting, of don't forget that we are talking about simply how to conceive a man. Annunciation is conceiving, she is conceiving Jesus Christ. But it would be, how to say, to finish, it would be nothing special, because if we go to the story of Adam and Eve and to the Garden of Eden, Adam and Eve were naked. They were created naked, and they wandered through the garden to the paradise naked, and they weren't ashamed. They weren't ashamed of their nakedness. That's after the fall, after the sin. Who could be what we know? One of the explanation what happened when they why they were banned to stay in the paradise was the sexual act. And we don't know. I'm just trying to explain. And that's I would like to say that eroticism and sexuality are something that are linked profoundly to the human nature, and it's not something even in the realms of Christianity and the Catholic Church, not to be something to be ashamed of, not at all. So I would like to finish. In the end, Krell's painting offers more than an image, it offers a message. The final message of the Annunciation is that the Incarnation is not abstract, it is real, embodied and deeply human. It happens not in grand gestures, but in quiet acts of love, trust and surrender. In portraying these, Krell does not break tradition, he fulfills it. He reminds us that in the mystery of Christ, humanity is not only saved, it is honored. So, 30 minutes I did not abuse my time. Thank you very much.
Thank you very much. I now open the discussion and I allow myself to ask both of you something. I find an interesting, very interesting correspondence between your lectures from the one special point of view. So the complexity of the heterophonic structures Thomas Noll presented us had a very, for me, strange and strong correspondence with this global time you presented, Bostian, divine global time. This coexistence of dimensions and this complexity, which is difficult to explain in words, but with the help of science and arts, it is possible to discover these words. So these are this short question for both of you, and then Frank Solina is the first one I see.
Please, Professor Noll.
So thank you very much.
Take the stage.
Uh,
Please, Professor Noll.
Thomas, are you beginning with a little comment about my...
I can, if the, or... So
I have a question or comment on the Annunciation. I think somebody else was already having
yes, but we have both first to answer Violeta's question.
So I have a little comment. In medieval churches in our neighborhood, there is sometimes this astronomical event, let's say, on the 25th of March, there are representations of the Annunciation where the sun, the moment the sun comes into the light of the
yes,
moves from the mouth or from the angel to Mary. So there is a kind of third dimension which covers the space which you mentioned, and I wonder whether Krell was aware of this old medieval thing with this waiting for the.
First to answer Violeta, and then Ioannis would like to ask a question. First to answer Violeta, so I would be very, how to say, modest, because I have made some conclusions about the quantum physics and the global time of God, but I'm not from the domain. I'm not competent in physics and in mathematics to answer with integrity. Nevertheless, I can answer to the question of Professor Noll. Yes, there was all the time. So I really worked hard on publications of museums, on encyclopedias, asking my colleagues, asking specialists of art, but they were not daring to say definitely, because if we discovered another Annunciation where there's no distance between, would be a problem for them if they say yes, there's the only one. I think it's the only one, but it does not change much. But I think it's the only one that exists. But for the reason I have explained, yes, there were two, how to say, there was two elements in the paintings to cover the gap between Virgin Mary and Angel Gabriel, the dove and ray. So the Holy Spirit in the form of the dove, or in the form of the ray, and so on, that was making contact. And it's very interesting, yes, that in your church. I did not know. I'm grateful to learn it. Have I answered comprehensively?
Thank you very much. So Frank Solinai, so first, and then Ioannis. Frank, you have to unmute yourself.
Yes, thank you. Well, my question is, how have artists historically depicted the Annunciation, and what symbols are typically included? If
Yes, the Annunciation. Yes, Annunciation is you have many Annunciations, because it's the crucial event in the Annunciation is the crucial event in the human history, because we can't before Christ, after Christ, and so on. And there was always, when I asked artificial intelligence, please, can I have an answer to the question, is there an Annunciation where the Virgin Mary and the angel Gabriel are not so distant one from another, or are merged? And the answer was no, there isn't. And then the explication, it would be unlogic, because, and then I'm explaining to my colleague, it would be in logic, and for that reason what Král made is heresy. In a way, it would be unlogic, because angel Gabriel is a messenger from God, and he comes from another reality, for another realm of existence, transcendental reality. They could not be together. There's a final distance. It has to be a final distance. It has to be a distance between two figures, because in a way Virgin Mary is a human, and she is submitted to the event. She's not co-creator of the event. Here you see Virgin Mary is sort of a co-creator of the event. If you take the Annunciation of Giotto, of every painter, also Picasso, and so there are Annunciation, but always following this logic. And
Thank you very much. So now Ioannis.
Yes, Ioannis.
Yeah.
thank you.
Thank you.
I enjoyed both presentations in a different way, each one. In my opinion, it is stretching and putative the relation between the second presentation and quantum theory. This is my opinion. I cannot see, if in our imagination, yes, we can see things linking. But however, one of the most representative bridges of art with science, which is the colloquium, is music with physics, as we noticed many times, and today as well. The quantum theory certainly has inspired musicians, as first speaker explained, and composers in a variety and imaginative way, I could say. But the question is, I do not know actually, if music has inspired quantum physicists. This is an interesting thing, the reverse, the several areas where the quantum theory has influenced the music, as we heard, Heisenberg principle, okay, superposition and entanglement as well, which is very important, the entanglement, the quantum entanglement, or quantum algorithms, Markov chains. There are various aspects of quantum theory and the use of quantum computing, etc., that has been explored as a tool in musical creation. So my question is, for the first speaker, if he knows, if music has inspired quantum physicists, and regarding the Bostian, actually, yes, it is something unique, this icon, because the beloved and favorite topic of Byzantine topic of this idea, with the Angel Gabriel and Mary, and later Peders is a beloved favorite topic, but Franz Král made something different, which very deeply and nicely, Bostian has described. I didn't know actually this kind, and I was eager to learn more. My question to the second speaker, if he knows if there is any pigment analysis of this icon, or any analysis if there was any overpainting. This is from my specialty point of view.
Okay,
Thank you.
Shall I? I have a very brief answer, only unfortunately. I mentioned this very first inspiration, which is, of course, it's not the music, it's the string. It's just the acoustical carrier for making music, which inspired the Browley and Schrödinger, so that to make an analogy between the finite the decomposition of the vibrating string into this series of multiples of the sinus, as of the frequencies of the sinus waves, as a metaphor, and then as a general, it became actually generalized for the modes of the orbits for the electron. So the violin served as a, so to say, as a model for understanding the electron. But I'm not aware of other inspirations in this direction. But it was the initial one, so to say.
Yes. So as far as I know about the annunciation, the canvas we see here on the screen, I was the first. There are perhaps Milcek Kumel, who is also a member of EASA, of the class 3. He wrote something about Kral because it's very attractive painting and very beautiful. And the brother Kral were the first to start to improvise. So that's the first generation, and they were promoters of that, how to say, courage to start improvise with static mythology, motifs, and so on.
Excuse me, Bostian, but Ioannis asked you something specific from the point of view of the research of the surface of the painting.
Pigment.
If I understood, so that there was a double question. First question, who was already working on the annunciation? I'm trying to explain that no one. And then, as far as I know, no, because I am related in a way to the family of Kral, and I would have heard. No, it has been painted on the material, and it was the first use of this material.
So nobody has
I cannot, but I cannot say 100%, but I would say 99.9%. That's the first, because it has been painted.
No. My question is not this one. Question:
yes.
If there is any technical analysis, any chemical analysis of the pigments, the colors, the dyes that are used to make this painting. That's my question.
No, as far as I know, no.
Nobody has done, okay.
Nobody has done, but it's very interesting question. Very interesting question. I would like to continue the debate with you. So,
and the second was overpainting. If he tried, the Kral, to make first a draw, and then he didn't like, and he started to make the final one. So how we can
no, it's a little bit. It's a little bit, as you can buy for 1,000 euros. You can buy one of the so with the pencil. So one of the first models of that. It's you can buy. I have seen. I did not buy, but no, it's not. It's like the idea. It's the original idea we see here.
Wonderful. Thank you very much. I see now two new questions. Ioannis Melanitis and Klaus Mainzer.
Yes.
I don't know who was the first one. So,
Professor Mainzer, please.
Mainzer, okay. Please, Klaus, can you...
Professor, you have to unmute yourself.
Unmute, please. Unmute.
Now that's only, it's not a question, but it's a comment concerning my impression after I have heard the two very impressive papers and talks this evening. For me, it was always an impressive period, the period between the two world wars in the 20th century. It is unbelievable. In politics, it was a terrible time, but on the other side, an absolutely fascinating time, full of innovation and creativeness. And nowadays, we are making comments to this period. What I mean is the emergence of quantum mechanics. In the first talk, Schrödinger was quoted, even with the German quotations. And in that time, and Heisenberg, his colleague, and others, and in that time, a new understanding of reality was emerging, not the classical ontology in the time of the empires, but all was becoming fuzzy and uncertain. And it is amazing how the different approaches in sciences and in arts were expressing that. Sometimes without knowing what is going on in arts as scientist or as artist, what is going on in science. But there were a few people who were bridging these worlds, and one of them was Paul Klee. I mentioned him in my comment in the beginning, because Paul Klee was a musician, and he was theoretically gifted, and he was a painter. And there are nice paintings which are quite similar to the tendency of the painting by the Slovenian painter here. Not in the sense of expressionism, but in his own sublime painting. And what all they are, or in modern in the classical modern music, we discussed it for several times here. There is now a new kind of order emerging, and these very precise concepts of quantum mechanics, as I mentioned, superposition and the uncertainty principle, is expressing this feeling of the time in a mathematical in mathematical terms. For me, it is absolutely fascinating to observe this kind of convergence and expressing the spirit of the time, especially in that period. That was only a comment because it was deepened by these very good contributions this evening for me. Thank you.
Thank you.
Thank you very much. And now Ioannis Melanitis.
Yes.
Can you?
I'd like to ask Thomas, first of all, since speaking about the Schrödinger equation, the very interesting thing I think in Schrödinger is, first of all, there are two ways to write the equation. The one is the time, containing time, the other not. He first initiated with the version of not including time, and this put him a lot of problems. There are some scriptures in his texts, in his lectures, where he's trying to handle the problem of time, because initially he describes the movement of a particle, and there's no time in it. The other problem I would like to pose you, if you're interested to explain me how you see it, is the fantastic number, the I, which is also present. What does, if he describes something natural, something that really happens, and so precisely, like the quad theory is the most precise theory we have. How is it? How can we explain the two solutions of the equation, and what does it mean for you by means of music, of sound? Thank you.
Yeah, so actually the two versions of the Schrödinger equation are important in our approach. The first is that we start with this, so to say, empirically given histogram. What is C major as a, so to say, as a statistics, and this, and the square root of this is then our first candidate for the wave function. And this, of course, is supposed to be the ground solution, which is stationary. It should solve the eigenvalue problem. So that's the first thing to do and to get done. And then the time-dependent equation is the entrance into dynamics. That is, and this is where I showed you the propagating wave, and so and there we are still not sufficiently clear where do we go with this. I'm not sure whether I should go too much into details, but I mentioned that the circle of fifths, the line of fifths, is our configuration space, while the data comes more from a chromatic concept. So therefore, we don't get a good fit, for example, between transitions in melodies between the notes and our data. So that is more an idea to get into harmony in fundament progressions where the fifth is, so to say, the governing interval. That's more where we go empirically. Concerning there's this other phenomenon of this Heisenberg relation. I'm not sure it's precisely going into the direction which you mentioned, but there is something I would like to point out. We have the two levels of reality, let's say, in quantum physics. The one is the propagating wave function in time, which is, so to say, hidden to the observer. And then we have the observables where we can make measurements. Actually, if we suppose that the human mind is an expert in understanding dynamics in this way, we should find both levels. And I think this is deeply related to an unsolved question from the 19th century, namely, how does our mind access its own activity, which was Fechner's question. And Fechner came with the idea that there is a mathematical relation between them, which is the exponential function or the logarithm, how one or the other way. But if we get into conjugated variables and all that, we need a higher dimensional version of the Fechner's law, which is known in physics and in mathematics, which is how you get from a Lie algebra to the Lie group, so with the exponential function. But then also we have a problem with commutativity. So when the one is not, there is no longer an isomorphism between the two. So, and therefore, this is a long speculation of mine, that actually music could be a candidate to finally understand this deep question. I mean, it starts with Descartes, then we get the phenomenology on the one hand, and then we have more the empirical brain measurements on the other side. But actually, it could be that that the mind performs observations on the one hand, which is then what is accessible to our experience, and on the other hand, there's just the activity, which would be the more the unitary version of the model. Yeah,
Thank-
so this is, but this is, so to say, behind the actual work which motivates me to do all this.
So it's so interesting. I come back to my first question. I mean, it was I spoke about you spoke about and you presented us also visually very interesting aspects of the heterophony. And the heterophony is this syntax structure in music. It's in fact coexistence of different melodies which have similarities. It's something it is not possible in fact to notate because the complexity of heterophonic structures is so enormous, and the heterophony structures exist also in the traditional music of different continents. In Europe, they disappeared in the western part of Europe, but Southeast Europe still have such heterophonic structure. And I just ask you if you could imagine a correspondence between this impossible to notate heterophonic coexistence of melodies and time with what Bastian presented with this eternal present of the very interesting, strange, unique painting.
I'm still unmuted, yeah. Yeah, I have to think about it. So what we do in our project for the computer music conference is very basic. It's just really using a one-dimensional wave function and looking at it simultaneously at different positions. I don't see an immediate answer in our own approach. But there is, of course, an interesting concept of time in, I think, more in directions of quantum cosmology, which is including complex time. So not only using the real number, but also the imaginary numbers. And I have also heard of inspirations in music. I think Maria Manona is working on this. So using complex time, which is there's this miraculous bit transformation in physics, in cosmology, which kind of solves a problem where one rotates the time in the complex space by 90 degrees. But I'm not sure whether this already answers the more
Phenomenology. Music
phenomenology.
phenomenology.
But there is something going on in mathematics which we have to understand. What is complex time? Yeah. What if time is not just one-dimensional, but actually not only two-dimensional, but complex means much more. There's multiplication, there's exponentiation, it's much richer than just 2 dimensions.
And it was so fascinating, your image is changing slowly, and these are like imaginary sounds, visual things. So I found it very interesting, and in fact close to this phenomenon of coexistence of melodies. On the other hand, I would say when you spoke about Bach and other music from Renaissance, and so it's interesting with your vision, analytical vision, we understand that composers had incredible intuition in doing things which have such a deep logical structure.
Yeah, I think that the history of composition is a history of discoveries, what the human mind can do it to itself. One often finds this idea that it's just habitation, that we get used to something by listening it 1,000 times. But I think that, when Chopin wrote the E minor prelude, he really made a discovery how to use 4 voices in a totally novel way. And so there, I think this is we don't yet understand what we already know musically.
Yeah, indeed. So anyway, this is a fascinating idea.
I can
Interesting
share. I
walkie-talkie.
mean, I made this last night. I created 10 minutes of. I just used frequencies, so to say, stacked, and then I applied this wave function, so to say that all the partials are kind of moving and changing their sound color. I can share this.
Oh, yeah.
It's not music, it's just a kind of sonification experiment, but I can. The question is where I enter the chat. Can I just?
In different contexts, such experiments
here.
could become art.
Yeah, I have, but how can I copy into the chat?
These vibrating images are, in fact, suggesting the infinite sound projections, and that maybe in our imagination could become
I think
followers.
now I can send Nachricht. Yeah, so this is a link to sonification. It's in a Google Drive.
Link to a sonification.
Yeah,
Aha,
of just
wonderful.
precisely this wave function which I showed you.
Yeah.
Yeah, but you should use earphones. Yeah, but
I notated. So wonderful.
I mean, I wouldn't really yet call heterophony. It is really more as a sound process, which is, so to say, so the partials are changing in as a kind of family of voices.
It's incredible. I would just like to mention some interesting thing that Bela Bartok, the famous composer, he was also ethnomusicologist, and he in his field researches, he recorded a violin player together with a taragot player. And then he sent the recording to a very good friend, also composer, ethnomusicologist, Constantin Brailoiu, and he told him, it's very strange, these peasants, it was in a very little village, are playing this similar melodies, and I don't understand how is it possible that they are not unisono. So one of them played fourths. So can you imagine at the beginning of the 20th century, it's a kind of new music because it was a very big dissonances. And Constantin Brailoiu told him, no, my friend, they desire to do this. They are not, they didn't study music, but they are, and this is in fact the first level of heterophony, coexistence of a melody with its variation. And this is in the very, very old traditional music. Also in different ways in the Far East and in the Southeast Europe still exists such phenomena. And this is not possible to put in a normal notation. And can you imagine, Boulez were fascinating for these ideas. And he wrote, for example, for very many instruments, such things, structures. And the composers is the first one who began to do such incredible landscaping of heterophony were also a lot of French composers, not only Romanians, and not only old. So that's why I was thinking, because in fact it's just having it's a lot of things that happens, is pulsation, but in fact it's static. It's coexistence of different ways of understanding time. And this has a very interesting correspondence with these unique paintings Bostian brought us. Yeah. And I like so much also his comments, the same.
Thank you very much.
Really.
I feel flattered. Thank you.
Yeah, to find, and we still have the feeling we have to stay, to remain and looking and trying to understand this incredible Christian message, something it's not possible to explain also in words. You have to accept this miracle. I mean, you have to accept something you cannot explain, and also scientists cannot also explain until the very end of the detail. No, Klaus, what do you think about?
It's another analogy. An ant will never comprehend how to say the mystery of old Greek grammar. and the human being will never comprehend what's the essence of God, what's the pink of God, what's the Annunciation, what's behind, So
Yeah, indeed.
Uh,
This is
to say Violeta to Yanis Lyrigis, because he asked about the technical aspects of the work, of the painting, as a painter. I have to tell him that it looks obviously to be oil on canvas.
oil on canvas, yes.
Yes, oil on canvas. And as I can see, the technique is a little reverse of the traditional Byzantine way, because in the Byzantine way, let's say you have a black surface where in general, where you come put the lights and you finish to the sharper lights at the end. But in this way, because it's canvas, it obviously has been, he started obviously with the black ones, the more darker areas. And as I can see, he did not put so much color on the light areas. He left the prepared canvas a little blank, so he put a little transparent color on the light. So I don't see
Thank you very much.
anything behind, but of course a further study can show if there were pentimenti or under drawings. I mean, it could be, yes, of course.
thank you so much. Yeah.
Thank you.
So I do not see Dušan, so I would like so much to ask Klaus Mainzer to say the last word of our first colloquium in this semester. Thank you so much. It was brilliant, brilliant presentations. I have the feeling I have to continue to think about and to discover. And please send us also your work, because we shall put it in the internet side. Thank you very much. Please, Klaus.
Yes, I can only say that was a fascinating opening event this evening, because in a very fascinating way, the different approaches in arts and in science, in music and painting were in some sense correlated. And I must say, I'm not only a mathematician, but I'm also a philosopher. And so far, it was actually fascinating, and we should go on. That was the opening event, and we will do that in the future with other events. And very nice comments also by you as participants. And we are, in the meantime, we are a community now.